Hello, everybody. Welcome you all to the discussion of a new subject known as turbo machines. So basically, we are studying with the subject turbo machines, where we'll be studying regarding the energy transfer which takes place between a flowing fluid and a rotating element. So now which you are seeing right now is the module number 1 introduction part. So in the introduction part, we'll be discussing regarding definition of a turbo machine, parts of a turbo machine, principle and working of a turbo machine, then types of turbo machine, as well as classification of turbo machines. So these points we'll be covering as we move on through the slides. So on the screen already I have given my email IDs as well as my mobile WhatsApp number. So if you have any queries, you can email me or send WhatsApp also. So now, the first important thing is, what is a turbo machine? So as I was telling you, if you split up this word into two small bits, that is turbo and machine. So what is meant by turbo? So turbo is nothing but it is a Latin term which means if there is a spinning action developed, a spinning action or a whirling action developed around a particular thing, we call it as a turbo. The best example for this one is, you have heard regarding the use of a Whirlpool washing machines. So the Whirlpool advertisement you have seen there, how happens that it is a completely spinning option taking place inside the machines, washing machines. So this type of whirling or spinning action, we call it as the term known as turbo. So therefore, turbo machine is nothing but it is developing a spinning action where with the help of the spinning action or whirling action, the energy transfer takes place between the flowing fluid and the rotating element. So in very simple words, you can say that all turbo machines, they are nothing but they are rotary machines. And in these machines, the energy transfer happens to take place from the flowing fluid. Keep this in mind. This is a very important point. That is continuously flowing fluid to the rotating part, or you call it as that part as also known as rotor, or it is also known by the name that is a rotating element, a runner or impeller. All the four words meaning is same itself. So here the energy transfer takes place between a flowing fluid continuously and a rotating element, or a rotor or a runner or a impeller. So when this happens, there is a dynamic action developed which is resulting in the direction, in the change of the pressure and momentum of a fluid. So many times you have seen these things also when you are moving on your vehicle, or you can say that when the fluid is flowing continuously, especially if you observe the water flowing during the flood times. So when there are some obstacles, it tries to move away from the obstacles with a greater speed. So what happens when it happens? This speed is achieved only when there is a change in the direction of the pressure, and due to there is change of pressure as well as the momentum of the fluid taking place. Similarly, here also in the turbo machines, the energy transfer, it happens to take place between a continuously flowing fluid as well as the rotating element, where there's a change in the pressure as well as the momentum of the flowing fluid. So generally, these machines, they're also known as power or head generating machines. So you can say that as a power or a head generating machines. So let us move to the next part. So if you observe this picture carefully, as I was telling you according to the definition, energy transfer takes between a flowing fluid. So you can see here there is some fluid flowing here. You can see it is also flowing here continuously. But as it is moving, you can see due to the change in the direction, it is experiencing change in the pressure as well as momentum of the flowing fluid. So this change in the pressure and the momentum, the change in the pressure and the momentum of the fluid, it is resulting in the energy transfer. So in simple words, if you observe here carefully, as I have highlighted here, generally the energy transfer may occur how? From the rotor to the flowing fluid may occur, or even it may occur in the reverse direction also, that is from the working fluid towards back to the rotor also. These two possibilities are there depending upon which type of machines we are preferring. That I will discuss in the next slide. Then, as I was telling you, whatever the dynamic action is there, how this dynamic action happens, it happens on the rotating blade itself. So you can see the rotating blade rows, where what happens due to dynamic action, the forces have been developed. So which type of forces have been developed? They are developed between, the forces are developed between what? The blade row and the fluid. So as you are observing here, as the fluid is passing through these blades here, here, continuously the dynamic action is being developed. That is, the force have been developed between the blade row and the fluid. So the components of these forces in the direction of the blade motion, what they are doing, they are responsible for developing, or they are responsible for the energy transfer which is occurring between the blades and a flowing fluid. So generally, this type of machines where you are employed, generally we are using in the windmills, ship propeller, steam turbines or gas turbines or hydraulic turbines, centrifugal and axial pumps, turbo compressors, etc. So if you observe, as I was telling you, the dynamic action is happening between the flowing fluid and the row of fluids. So this is the first row of fluids, second row, third row. So like this it goes on. So as a result, due to this, what happens? The energy transfer happens as there is a change in the pressure and the movement of the fluid as it passes through every set of row of blades. This is regarding the simple procedure and the working phenomena. Now, so in the previously I was telling you, we are deciding which type of machines we need. Either the energy has to flow from the fluid to the rotor or from the rotor to the flowing fluid. So in that case, the types of turbo machines generally which we are preferring for our, there are two types of turbo machines, and they are nothing but whether we are choosing them because depending upon this phenomenon, that is whether work is done by the fluid onto the rotating element, or the other case, that is work is done on the fluid again by the rotor. The only difference is here work is done by the fluid. Keep this in mind. Work is done by the fluid, where here it is work is done on the fluid. So if it is work is done by the fluid, then we call it as power generating machines. Keep this in mind. So the power generating machines means all kinds of turbines. They are power generating machines itself. If work is done by the fluid, if work is done on the fluid, then there are examples of power absorbing machines. That is all centrifugal pumps, all kinds of pumps, compressors, blowers, even the fans which are using, they are all power absorbing machines. So as I was telling you, if the work is done by the fluid, power producing machines or power generating machines, that is all kinds of turbines, it may be hydraulic turbines, gas turbines, steam turbines, they are all examples of this particular case, power generating machines. If work is done on the fluid, all kinds of pumps, compressors, fans, blowers, they are examples of power absorbing machines. Another important thing is always for a power absorbing machine, we are using an input shaft, which means work is transferred to inside the machine. So that is the input shaft towards machines. Whereas for the power generating machines, we are preferring an output shaft. This is the discussion on regarding the types of turbo machines. Next, this is the very important part, that is which are the major components of a turbo machine. So if you observe carefully here in this picture, as well as the animated video here, we are having any turbo machine you take, it is having four important parts. The first part which you are going to see is, as he has told, here should be the vane. So a vane which is carrying a rotating element. So if there is any rotating element or a blade which is having rotating element, we call it by three different names. Already we have discussed it. It may be a rotor, impeller, or a runner. So if you observe here in this picture, on a shaft there is a rotating element, that is a rotor. So this entire part along with these blades which you are observing here, 1, 2, 3, 4. Yes, this is a rotor or a rotating element. This is a rotor or a rotating element. So if you observe in this particular video, this is the number 1, that is the rotor or a impeller or a runner or a rotating element. Second important thing which we have discussed here is regarding the discussion of vane. So a guide vane, he says there is guide means what? It is a stationary element. Stationary element means it is not rotating, it is in stationary position. What is the purpose of this using this guide vane? It is especially used for providing the direction. We call it as proper control of the flow direction. For which purpose? For the energy transfer, you can say that energy conversion process. So if you observe here in this particular figure, this one, I will show it by another color, which means which is easy to understand for you all. Preferably we shall go it for the blue color. Okay, so this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are all guide vanes. They are stationary. Why they are stationary? If you observe their mountings, where they are being fixed, they are being fixed to this part. This is nothing but it is the covering, or we call it as housing. So that is the reason that these blades, they are not under motion, they are not rotating, they are stationary. That is the reason we call them as guides. Why? They're responsible for allowing the flow to pass through these blades continuously, changing the direction, which results in the change in the pressure and the amount of the fluid due to which energy transfer occurs. So now, if you observe in this animated video here, this particular part, yes, this particular part, if you observe here, I will show it by another color. Wait. I will show it as a black color, which means easy to understand for you. Yes, this particular part, that is this particular part, it is a guide vane, that is number 2. The third one is, he has already told, it is an input or output shaft. So if it is a power generating machine, it is an output shaft. If it is a power absorbing machine, it is an input shaft. So there you may have an input shaft or output shaft. So this is the shaft which you have seen already here. So here in this picture, this is number 3. That is whether it is an input shaft or an output shaft. Then this entire assembly, that is the rotating blades, guide vanes, and the shaft, they're all incorporated within a covering structure. This particular covering structure, we call it as housing. That is the number 4. That is housing. So housing is nothing but it is a casing structure which is covering which one? All the other 3 parts, that is the rotor blades, guide blades, and the shaft. So now if you observe the left side sketch carefully, just I will show you. This is the entry of the flowing fluid here in this part. Now if you observe at the first, we are having stationary blades. It changes its direction. Its speed is a little bit increased. It passes through this rotating blade. Again changes the direction. So like this, what happens? There is a change in the direction of the fluid, due to which it results in the pressure and movement of the fluid, and the energy transfer happens. So basically, these are things we need to know, especially when the energy is being transferred from a flowing fluid to the rotating element. So if you observe the video once more now, yes, as I was telling you, this is a rotating element rotor, fixed blade guide vane, input or output shaft, and this structure, gray color, it is the housing itself. These are the things you need to know. Now, the classification of turbo machines. So any turbo machines you take, that classified based upon these four factors. The first factor is regarding an energy transfer. The second factor is regarding the working medium. And the third factor is regarding the type of flow, energy transfer, working medium, type of flow, and the direction of flow. So any turbo machine you take for a study purpose, they are all classified based on these four factors itself. In that, the first factor which we will be seeing right now is the energy transfer. So energy transfer, as I was telling you, either you have to transfer, either there should be an energy output or there should be energy input. So if there is an energy input or if the work is being absorbed, we call those machines as power absorbing machines or power absorbing devices. So here we are preferring which kind of shaft, which we have discussed previously, that is the input shaft. Why? Because here how the energy is being transferred, it is being transferred from the shaft to the fluid. Here the energy is being transferred from the shaft to the fluid. So these are the power absorbing machines. So all fans, all pumps, all blowers, all compressors, they are power absorbing machines. If the vice versa happens, that is the energy is transferred from the fluid to the shaft, that is the output shaft, we call it as power producing machines or power generating machines. That is all kinds of turbines. It may be the steam turbine, gas turbine, or hydraulic turbines. They are all examples of power producing machines. This is the first factor. Second factor is working medium. Which medium you are preferring? Which media is applying through the devices? So generally, we are having two cases. The first case is regarding the discussion of pumps. So when you go for the pumps, generally you have seen you are using pumps at your home, you are using pumps in your fields, in the industries, everywhere you are using. What is the main purpose of the pumps? Nothing but they are delivering the water to the required height or required distance. So generally, many cases, if you go, we are using the working medium for the pumps as the liquid itself. That is why liquid, because other than water also you can transfer the oils in the oil industries or any other liquids also. So that is the reason that the working medium which are preferring for the pumps is naturally, or many times it is the liquid itself. But in that, more particularly, we are preferring as water for many applications. Apart from this, the another case sometimes where we cannot prefer the water or any other liquids, we go for another media that is known as air. So where you are preferring the air, especially if you go for the rockets, jets, or some of the gas turbines, that is the steam turbines, compressors, blowers, you cannot use a liquid. So here we are using the pressurized air itself. The air is being compressed at higher pressure. That is here the working medium, they are gases. And many cases, the working medium naturally, many times we are preferring air as the best working medium for all the cases. So on working medium, we are having two conditions. Either one is water, especially for the pumps. If you are going for the turbines, compressors, blowers or fans, then you are using gas as the working medium, or and especially in that, air is the best preferred gas. This is the second factor. Then when you go for a third factor, that is a type of flow, which type of flow is happening. So already in our fluid mechanics, we have studied, we are making some assumptions. That is, some of the fluids are incompressible, compressible. So in the type of flow, we are having two criteria. One is an incompressible flow, another one is compressible flow. So generally, in our turbo machines, if the liquids and gas which are flowing, they are having a low Mach number. So already I studied what is Mach number. Yes. So the fluids which are having lowest Mach number, we are preferring those as the incompressible flows. They are nothing but they are the incompressible flows. So if the examples for those cases are, that is the hydro turbo machines, commercial blowers, fans, etc. So generally if the value is less than 0.8, it is the thing, but it is a lowest Mach number. For a compressible flow, the gases which are having highest Mach number, we are preferring the compressible flow conditions. So example for these cases, for highest gas, highest Mach number, that is the high speed or high pressure compression ratios, especially used in steam turbines, gas turbines, we are preferring this one. Then the fourth factor is regarding the direction of flow. So if you observe here at the picture below, here the fluid is flowing in this direction and the shaft is here, which is rotating along this particular axis. So if you observe here carefully, there are a set of, this is a rotating blade which has been hatched here. At the side we are having a stationary blade. As the fluid flows, how? In the axial direction of the rotating shaft. We call those machines as axial flow machines. So if the fluid is flowing how? Parallel to the axis of what? Inside the blade passages, then generally we call them as axial flow machines. Examples: turbojet engines, fans, some of the Kaplan turbines and steam turbines are the examples of the axial flow types. Similarly, even we have for the radial case also. Yes, if you observe here, the second case, that is the radial flow machines. So as I was telling you, if you observe in the picture carefully, here the flow may be radial inwards or radial outwards. Here the flow may be radial inwards or radial outwards. So if you observe here carefully now, here the water is entering radially. Yes. And then it is leaving out radial outwards also. So we call those machines as radial flow machines. So the flow is passing through the vein passage of the fluid passes. We call them as radial flow machines. So the best example for this one is, that is the centrifugal pump. Similarly, if there is axial flow at the entry and radial flow at the exit, or radial flow at the entry and axial flow at the outlet, so then those type of machines we call them as mixed flow machines. So as I was telling you, either fully radial or neither fully axial, we call those machines as the mixed flow machines. So if you observe here at the entry, here it is entering axially. Now at the exit, if you observe, it is leaving radially. So it is a case of a mixed flow machine. So the best example for this one is Francis turbine. So if you now observe the video carefully at the sides, you can see, yes, here the flow enters radially and it is also leaving radial outside. We call this as radial flow machines. At the same time, if you observe here in this case, it is entering radially, but how it is being discharged? It is moving axially because this shaft is along the vertical axis. This is an example of mixed flow machines. So today we shall stop here. Again, in the next session, we shall continue from this part itself. Okay. Thank you, students.